We'll get started. Regarding the tic-tac-toe assignment, it's due today. I would say when that deadline comes, just turn in what you have. If you need to, if some of those test cases aren't working for you, add some commentary in your homework to kind of explain to the reader or grader why the test case isn't working, or he needs to modify the test case in order to get it to work. I would just explain all of that. But yeah, I would just say turn in what you have, even if it's only 50 or 60% operational or something like that, and we'll do our best in grading it accordingly. Okay. Today we'll start talking about getting data into R and scraping with RVest. So we're going to start transitioning to using packages in R. Okay, so kind of the first few weeks we got into the nitty-gritty of R programming and data structures and how functions and environments, all of that work in R. And now we'll take a look at some of the packages that are very useful to have and to use in R. And these are all very high-quality packages that really make our life easier as far as dealing with R and getting things to work. Okay, so we're going to first start by just talking about importing data into R. Okay, and so the basic commands are things like scan. Scan just reads in a file, kind of as raw input. Doesn't do any kind of handling there. Read line is like scan, except it's for the terminal, and it gets input from the user. And then you've probably used read.csv, which is a modification of read.table's default values. But read.csv you would use to load up a CSV file, which is basically a plain text file with a bunch of commas separating different values. And I imagine you've used these before. A lot of the import functions have been made stronger and more robust and faster via some packages, and so I strongly recommend you at least install Package Reader. Okay, but these other packages are also very good. Data.table also is notably very good as well, and these are just ways to read your data into R, and so Library Reader will read in CSV files and whatnot, except it works a lot faster than read.csv. Read_CSV is much faster. You also have Read Excel if you've got Excel files to work with, and if you need to work with other programs like SAS or Stata, things like that, we have Haven, okay, SPSS as well. And then data.table handles some really large data files. So if you're going to do something with a DataFest and you've got like a 3 gigabyte file of data, probably data.table is the way to go there. And so all of these things, you can read more about them. Data.table has a vignette. A vignette is kind of like a short example of how it can be used, as opposed to the reference manual. The reference manual just lists off the functions and all the details of each function, but the vignette will be an example of how it's used. Okay, and then there's also a little webinar. Basically someone recorded their screen using these packages, and it's also good. Maybe it's about 50 minutes if you have questions about any of those packages. Worth checking out. Another package I recommend is Library Downloader. Okay, this gives us the download function, which is different So R has a download.file function already, and that allows you to go onto the internet and download a file. Except today on the internet, pretty much everything you do will have a HTTPS secure connection, okay? If it doesn't even bother listing it. This is just regular old HTML. You know, IMDb, also just regular HTML. But on a lot of other places, it's going to have a secure connection. And download.file is unable to handle secure connections, and so Library Downloader is a good alternative to use that allows you to handle HTTPS. Okay. There's also like rcurl, but it's like confusing to use. I shouldn't say that. It's a little bit more work. That's all. Okay. Also, when dealing with imported data, if any of your columns of data has date information, I strongly recommend that you load this package Lubridate. Okay, and this allows you to handle date information a lot easier, and it makes it a lot more smooth. Because without Lubridate, it can be very frustrating. All right, so let me just kind of show you. Let me delete all of this, and we'll come over here. Okay, so here I've got 3 text strings, okay, representing different dates. So if I click this here, this is just a string. sdate2 is also a string. These are just character things. Now, how do we turn this into something that R recognizes as a date object? Well, with Lubridate, it's very easy. We just say, oh, look at this first string. It's in the form day, month, year. So we're just going to call day, month, year on the string, and it turns it into a date. Okay, and interesting enough, the way the dates are calculated is it's just it's like the number of days since some arbitrary date. It's like January 1st, 1970 or something like that. Is how R keeps track of dates. But basically we just turn these things into days and dates, and and R handles this. Okay. Over here we've got January 1599. If we want to turn it into a date, with Lubridate we just say month, day, year on this string, and it understands, okay, that's the year 1999, January 15th. Okay. Over here I've got entirely different function, 12/15/2001, also a date in the form of month, day, year, and there it goes. So even though these things look very different, R understands these, or Lubridate understands that these are dates, and it can handle these as well. If you didn't use library Lubridate, you'd have to use the function as.date. Okay, and if we look at the help for as.date, we'll see all sorts of stuff, and it's really off-putting in terms of how to use as.date. Okay, and so if we wanted to turn this first string into a date, we would have to say as.date, take the string, and then we have to give it a string indicating the exact format that the date has been written in. Okay, and so in this case, it's day, month, year. Month is written out as a word, so we have to use %D, %B, %Y to indicate that. Over here with this thing, I've got January 15th, comma, 1999, and to indicate that, I have to write, I've got %B, because it's written out as a month, %D for the day, put in the comma, a space, and a %Y. And if I mess this up in the least, it's going to fail. Okay? And then to indicate that we've got month, day, year over here, I have to use %m because the month is now expressed as a number, and things like this. All to say, it's a pain to have to do things this way, and it can be very frustrating. So Lubridate just makes your life easier, and that's all. Okay. Let's take a look. We're going to take a look at the package rvest. Okay, and rvest allows us to go onto the internet, find an HTML web page, and then scrape that HTML and pull out pieces of information that we want. Okay, to use rvest, we're going to have to make use of something called the selector gadget. Okay, and so you would go to this web page, the selector gadget, and there's like a little video on how the selector gadget works. And to get the selector gadget to work, all you would do is you would just take this link that says selector gadget, you'd click and you would drag it to your toolbar or your bookmarks bar in your browser. Okay, and then that would show up here, and then you can click it, and then that would activate the selector gadget on a certain web page. Okay, after you install library rvest, you can check out the vignette on selector gadget, which is like an example of how this thing works. But before we really get into the usage of rvest, I want to talk about pipes. Okay, loading rvest will automatically load package Magritte. This is the what is that? This is not a pipe picture. You guys know this? Treachery of images, right? And so the caption says this is not a pipe because it's a picture of a pipe and not a literal pipe. But anyway, this is what we have. Okay, this is our pipe. Okay, percent greater than percent, and this, what it does is it takes the output of one function and it pipes it into another function. Right? And maybe in R, probably in your code, you've had to do this where you want to take like the output of one thing and then you want to run another function on it, and so you like nest all of these functions inside of each other, and at the end you got this really monstrous line of code, and you have an idea of what it's doing, but then if you show anyone else, then it takes a while to explain because everything's kind of nested in, and you have to say like, oh yeah, I was doing this, and then and something like that. So let's say we wanted to do a simple example here, right? We're going to take all the integers 1 through 1,000. Of those, we want the ones divisible by 3. And then we're going to take those that are less than 200 or greater than 800, and we're going to find the square root of those resulting values. So we're going to take from basically from 1 to 200, the value is divisible by 3. 800 to 1,000, the value is divisible by 3. And then all of those things we're going to take and find the square root. If we wanted to do this in one line with nested functions, it would look something like this, okay? On the outside, because it's the last thing I'm doing, I'm going to take the standard deviation. But what am I taking the standard deviation of? You know, somewhere in here, I'm subsetting the vector 1 through 1,000 based on those divisible by 3. And then of those, we're finding the ones that are less than 200, and of those, finding the ones that are, like, this succeeds in doing it, except if you just saw this, you probably wouldn't fully recognize that this is what it's doing, okay? Yeah, maybe you can decipher it, but it would take a while to do that, right? So another way that would probably be better in terms of clarity is you just say, all right, I'm going to start off with the vector 1 through 1,000. Then I'm going to store that as A. Then I'm going to subset A, where A is divisible by 3, and we're going to store that as B. Then I'm going to subset B, where B is less than 200 or B is greater than 800. And we're going to store that as C, and then I'm going to take the standard deviation as C. Okay? So I think this is a lot more clear in terms of what is happening, except the side effect of this is that we had to create A, then we had to create B, and then we had to create C, and finally do that. So piping allows us to kind of use this format without the need to create intermediary values to do the next operation. Okay, so here what I'm going to do is basically I'm going to take A, 1 through 1,000, and then I'm going to pipe it into here, okay? So pipe it just like this, subset A, where A is less than, where A is divisible by 3. So I'm going to pipe that, and I'm going to say the dot represents kind of the previous value here. So we're going to take subset that, where it's divisible by 3, take the result, pipe that into the next subset where it's less than 200 or greater than 800, and then pipe that into the last function, which is take the standard deviation. So it allows us to do this form without having to create intermediary values in between. By saying this is A, now this is B, and this is C, and this is D, we can just continue to pipe, and we gain the clarity of understanding the steps without the need for things in between. Does that kind of make sense? What we're doing here? I think it'll make sense when we actually do our demo with Arvest on the internet here. So yeah, I do strongly encourage you to take a look at Magritte, the things, and then to in order to avoid having to type out % and % or % greater than % you can use Control-Shift-M on your keyboard, or Command-Shift-M, and it just keeps typing things out. Okay. All right. So let's take a look at what we will do with Arvest. Okay. So here I'm gonna load up these libraries: library Arvest, Stringer, and Data Table. Okay. You might need to install those packages on your computer. All right. And then what we'll do is we're going to visit this web page. This is the web page for the Lego Movie on IMDb. Okay. You guys see the Lego Movie? Yes, no, maybe. It's great. What about the Lego Batman movie? Also excellent. I haven't seen the Lego Ninjago movie, but it's on my to-do list. But anyway, all right. So, okay, so here is, oh man, and Thor Ragnarok comes out. Oh, but that's like 2 weeks away. All right. We'll have to wait. Okay, so let's say we want to extract pieces out of this website, okay? So what Arvest basically does is, if you right-click anywhere on the web page, you can click View Page Source, and we see all of this code, right? We see all of this HTML, and HTML is written with all of these little like tags using kind of like a less than and a greater than sign that establishes a tag, and this is how it lays things out on the page. And so everything on the page is accounted for with these tags, and then the browser then takes all of this raw text and says, oh, you want me to put a link here, and you want me to put the text here, and we're going to lay it out looking like this, okay? So somewhere in that source, we would find this text that says 7.8 out of 10. This is the current rating for the movie, okay? And so I can say search for the text 7.8, and here it is, okay? This is the rating value 7.8 inside all of this text here, okay? So if I wanted to extract this bit of information out of the web page, right? As people, we would look at this and our eyes go, this is 7.8, okay? But the computer doesn't get the advantage of a nice layout on the screen, and instead, it has to read through all of this text, right? And if we had to read through all of this text and someone said, find out what the rating of the Lego Movie is on this thing, we would not have fun doing that. But the computer is very efficient, and this is where the selector gadget comes in. Okay, so if you have the selector gadget loaded into your bookmarks bar, and again, the way you do that is you go to the selector gadget website, and you just click and drag this link to your bookmarks bar. Then it shows up there, and then you would click this, and what it does is it loads up this little widget down here, okay? and you would just highlight it, and you see all of these orange boxes appear, and you just hover over the thing that you want. So I want to get this number 7.8. So I click that. That number 7.8 turns green, and then we also see a whole bunch of stuff on the screen turn yellow, okay? And it says 594 under here for clear, okay? So that means if I were to use this tag span, R would extract 594 elements out of the page. We don't want that. We just want to extract the number 7.8. So basically, I would just hover over anything that's yellow here, and when I do that, I get a red box, and I click that, and basically all of those other things that I didn't want get deselected, okay? And so now it says if I use it, I would end up with 3 values extracted. So if I look carefully, I see, oh, you know what? I don't actually want this number 10 selected, so I'm going to click that. And then finally, it says you're only going to select one thing on the page. The way you would select that is by using the tags strong span, and that will end up getting that value 7.8. Does that make sense? So the way we would do this is we would go, after we load up library rvest, we would tell rvest read _HTML. This, you give it the a website address, and when you say read HTML, it's going to read the HTML. It's going to read in all of this stuff into R, and it will store all of this into, for here we're going to store it into Lego _movie. Okay, so I do that. It reads the that page's HTML into this thing Lego movie. All right, and if we look at Lego movie, it's stored as a structure of 2, but it's all kind of, it's really messy. Okay, what we want is out of this HTML, out of all of this stuff, which is now stored in R somehow, we want to be able to extract this value 7.8. Okay, so the way we're going to do this is we're going to say take Lego movie and throw it into the function HTML nodes. HTML nodes takes in the argument, what CSS tags do you want me to use? Okay, and in this case, based on the selector gadget, we said the way we're going to get this value 7.8 is by using kind of this selection strong span. Okay, that's how we would get this value 7.8. So I'd say take HTML, take the Lego movie, and then throw it into HTML nodes and do strong span. And if I just run it there without running anything further, it pulls out that node, span item prop rating value 7.8/span. So it basically has gone into this thing, and it has pulled out this piece of the HTML code where we have that number 7.8. Okay, so rvest is very good at being able to find the thing that you want. Okay, and what we don't want this entire tag, we actually just want this number 7.8. So we say I want the text contained in the tag. So we're going to take this output, span item prop 7.8, and we're going to feed it into the function HTML text. Okay, and so when I do that, now it's just going to take the text here, 7.8, and returns back the value 7.8. And if I want to turn this into a number, I just feed it into the function as.numeric. Okay, and there we go, 7.8. So we can see with the usage of pipes, I don't have to have these functions nested inside of each other and get this complicated thing that obscures what I'm trying to do. We can see very much kind of like this linear path of what's happening. Okay, and so we would take all of this stuff, and then we would say store all of that into rating. Okay, so rating is going to be the result of this, and indeed rating, it has pulled out 7.8 for the rating of the Lego movie. Okay, what you select can actually be a vector of values. It does not have to be just a single thing. So I can come down and I can scroll down, and we can say, okay, who are all of the actors that were in the Lego movie, right? And so we have Will Arnett and Elizabeth Banks, Craig Berry, Alison Brie, all of these things. And so I can click select your gadget here, and if I want to extract the list of actors or the cast, I would click one of these names, and it selects a whole bunch of stuff. Okay, and it actually for some reason selects the box as well around the name. So I don't want the box. I'm going to just click that, and here we can just see it has indeed just selected only in yellow. These are the things that it's going to extract. It just wants that's what we want. We're going to just pull out the names in yellow here, and so the way we're going to select that is by using the tags item prop. So I'll use that, and it's going to pull out 15 things is what it says when we use that set of tags here. So to do this, yeah, the last time I did this, it gave me a different set of nodes. This time, yeah, so I would just take Lego Movie, right? So the Lego Movie is kind of the XML document, and I would feed it into HTML nodes and say I want the nodes item prop, okay? And it pulls out those 15 nodes which have class item prop and something like that. And from that, I want to extract just the text. And when I do that, indeed, I get the names Will Arnett, Elizabeth Banks, Craig Berry, Allison Brie. Okay. And so here I'm going to just do this. Last time I ran it, it gave me a different set of tags to use: title, cast, item prop, span. It's basically the same. And then so if I ask, what came out of cast, then the cast is now just a character vector with 15 elements, and the names in that character vector are Will Arnett, Elizabeth Banks, and Craig Berry, and things like that. Okay, so here now I have a character vector of the names of the actors in the Lego Movie. Is that okay? So that's using HTML nodes, right? And you can, so here we've been using HTML text, but you can actually also pull out attributes, okay? So in the HTML page, if you want to see like where an image is, you can click this thing, and we don't want this, but okay. So here it's a little bit strange, but this is kind of how I would select the images. And what we might want is we might want to get the not the text, but we wanted to get the path of the image, okay? And so to do this, yeah, this is the node that I'm going to use. I would do Lego Movie, extract these nodes, and from that, rather than extracting the text, extract the tag src, okay? And so if we were to go into here and I look for the tag src somewhere in here, it would kind of give us some the path to some image here, right? And so if I run this, okay, and I ask what is in poster, I get two URLs back, and then I can take this, and if I go to that website or web address URL, I get the image for that movie, okay, or image that was associated with that. And this one I think is the other image that was in that heading section. It's this one, right, with Batman. And okay, and so with that, if you wanted to, you could then feed this into a link like download, right? Downloader. Okay, well I don't know what I'm doing, but you could throw in the URL and then download those files if you wanted to. Okay, so that's so you can extract based on the attributes. Okay, and you can even extract longer things, such as on the web page there is user reviews. Here's a 10-star review for the Lego Movie. I didn't write this, but I was the only adult who didn't bring kids to the theater, and I was leading the clapping when the credits rolled. Maybe I did write this, but so here we have, you can pull that out, okay? All you have to do is you select your gadget, pull out the node, and it would extract the text, okay? And so if we ran that here, here's the text exactly as we have it, right? And if you wanted to do some text analysis or sentiment processing, you could do that. Okay, so that's all fine and dandy, and that in of itself is pretty exciting. But I think the next part I'm going to show you is totally, truly amazing and awesome. Not that everything I have showed you was not awesome, but this really is. What we can do is we can create automated browser sessions, okay? And so instead of using the command read HTML, okay, so this will read in a page and treat it as kind of like you read in the page, and we're going to parse out the HTML. Here we can create an HTML session. And what this will do is basically, when you surf the internet, every browser that you have open, this is a session, and you can then, you can say, like, I really loved the Lego movie, and I want to know everything about the actors. So I want to know about Will Arnett, and I'm going to click Will Arnett's page, and I'll be like, oh, Will Arnett is Canadian, and he was in Arrested Development, and he's also BoJack Horseman, and they're making the Nut Job sequel, and there's a short called Batman is Just Not That Into You. Maybe I'll have to check that out. So, we can spend hours, literally, going through each of these pages, and now I'm going to investigate Elizabeth Banks and learn about Pitch Perfect 3 and I don't know, whatever it is that we're going to do here, okay? And you can go through each of these, keep continuing clicking links into this endless rabbit hole. But we can also have the computer do it for us, okay? And so here I'm going to create a session, and all we do is we give it the address of the web page that we're going to go to, and we're going to say open a session, and we're going to store the session right now as S, okay? And then I will say, you know what? I want to, starting on this web page, which is the Lego Movie webpage, I want to follow the link that says Will Arnett. Okay, so we tell R to follow the link that says Will Arnett. Okay, and then so that would be the equivalent of clicking this page, and then it says we're going to read in the HTML. So that would be the equivalent of doing view page source and taking all of the code on the Will Arnett page and loading that into R. So I'm going to do that. I'm going to say start at that session, follow the link Will Arnett, and read in the HTML. And we're going to say that's going to be, we're going to store that as Will page. Okay. And then let's say I'm on this page, and let's say I want to know, okay, all of these movies and shows that Will Arnett has been in. Okay. So here I could use select your gadget, and I would highlight the thing that I want. Okay, this says now selected way too much, so I'm going to click over here and say I don't want that, but now it's selected too little. I actually do want other things, and so this looks appropriate. So it's selected Teen Titans, Show Dogs, BoJack Horseman, Nut Job 2, Last Week Tonight, and it looks like it's got the title of the things that I want to extract. Okay, so I'm going to copy this. This is how we would select that, using the tags B and A. And so I would say from the Will page, which we created via the session, use HTML nodes to select the nodes B and A, and from that extract the text. Okay, so if I do that, this looks quite successful at extracting all of the titles of the kind of the movies and shows that Will Arnett has been in. Okay, kind of starting with the most recent, going through all of this stuff here, okay? All right, so that was just for Will Arnett, right? Okay, earlier from the IMDb Lego page, we had extracted the cast list, right? We said from the Lego movie page, extract out the cast. And so here I have the cast, and this is kind of, 15 names from the cast list. So what I can do now is I can create a loop telling R, do something similar that we did for Will Arnett, except do this for every single actor in the cast list. Okay, so what we did was we said follow the link for Will Arnett, go to Will Arnett's page and extract the movies that Will Arnett was in. But now that we're done with that, follow the next link. In this case would be Elizabeth Banks. Go to the link for Elizabeth Banks' page and extract and maybe pull the movies that Elizabeth Banks was in. All right, so in this case, we would go there and we would get the Happy Time Murders. That sounds... And Pitch Perfect 3 and Cochrane and Curb Your Enthusiasm. So we would pull that out. Okay, and then... Okay, and then we would follow the next link for Craig Berry and all of this, right? Okay, so to do that, I'm going to just create an empty list where I'm going to store my results. And I'm going to call this cast_movies, and this will create an empty list right there. Okay, and then for each page, what we want it to do is we want it to go starting with Will Arnett, then Elizabeth Banks, and then Craig Berry. We're going to have it iterate through each of these names. So here I'm going to do for I in cast 1 through 3. It's not actually each thing. Again, we're giving it a vector, and it's going to go through each name. So each thing here, I is going to be the actual name: Will Arnett, Elizabeth Banks, Craig Berry. So we're going to start off there, and for each one, we're going to have it start at the session, follow the link, and read in the HTML. And that's going to create our temporary actor page. And then, from the actor page, we're going to extract out the nodes BA, which gives us the list of movies or shows or projects that the actor was involved in. And out of that, we're going to extract the HTML, right? So this worked when we did for the Will_ page. And then perhaps we don't want just the shows or movies that they were involved in, but maybe we want the year that they worked on the project here, okay? And so here, if I want to extract the year, I would use Selector Gadget, and I would hover over the year, and then and it says just do .year column. Okay, so that seems easy enough. So I'll do that. Okay, and so here we'll try it out with the Will_ page. Will_ page. We're going to do HTML nodes. And we're going to pull out year _ column. This looks okay. And if I do HTML_ text, okay, it pulls out the text, but it looks like a whole lot of it includes like these special characters here. So I can probably do a few things. I can probably do string trim. Okay, and that trims out the extra white space. Yeah, maybe I'll do that, okay? Over here I did string extract. This is why I loaded up library stringer. We'll cover stringer later, but here, yeah, this is what I'll do. So for each one, we're gonna just pull out the nodes year _ column, and from that, the text, and then we're gonna just trim that string, okay? So that's what I'll do here. So it's pretty much the same here. Oh, and we also want just the first 10, otherwise it's too much. Okay, so here we're going to extract actor page. We're going to extract the year column, take out the text, take the top 10, and then just trim that text down. Okay, and we're going to store that into years, right? So here we're doing cast movies, bracket I. So we're going to create a thing, because for the first one, the first cast member will be Will Arnett. So we're going to create an element in cast movies called Will Arnett, and then within Will Arnett we'll have movies, years, and then we'll also have name. Name is going to just be, we're going to just repeat Will Arnett 10 times, the number of times we have cast movies here. Okay, so here I'll go ahead and I'll run this for the first 3 entries in cast. So it'll go for Will Arnett, Elizabeth Banks, and Craig Berry. So I do that, and it obediently goes and it follows the link for each of those pages. And now we have cast movies as a list, and I can ask, what's the structure of cast underscore movies? And we can see that it's a list of 3, and those 3 elements are Will Arnett, Elizabeth Banks, and Craig Berry. And Will Arnett itself is a list of 3 with movies, years, and names. Elizabeth Banks itself is a list of 3 with movies, years, and names. And Craig Berry itself is a list of 3 with movies, years, and names. Okay? And so we have successfully kind of extracted this, and because it worked with kind of the first 3, we can then expand this to 10 or 15. Now, when you're running automated browsers, it is bad manners to make 1,000 requests of a website within a few minutes. Okay, it's bad manners to repeatedly hit a website and request pages or information and things like that. And in fact, if you do it too much, the website might think that you are trying to attack the website, and they might block your IP. It's also a possibility if you have these, if you use a bot to do these things, which is effectively what we are doing. But most likely, if you're doing small projects, it's not going to be a problem. But if you're going to try to scale this up onto a big version, you got to be careful, okay? But here I'll just go ahead and I'll do it for the first 10 actors in cast, okay? And so it's following each of these things. And it takes a little bit of time because it's the internet. The internet is not super fast, okay? And so going to each page takes a little bit of time. And then from each page we're extracting things, all right? And so now if I look at the structure of cast underscore movies, now I have, at the top level, I have a list of 10, okay, with, and then each of those subsequent lists are lists of 3 with, and those have just 10 items in each, okay? And so from there I can kind of just look at the first one. This is for Will Arnett, and it's a list of 3 with movies, years, and name. And then I can use this command, rbind list. This is something that works if you've got nicely formed lists with equal numbers here. And if I do that, then the result is, I think, is quite nice. Although perhaps maybe this text got somebody, because of this person, the 100-year-old man who climbed out the window and disappeared, it altered the way it displays on the screen here. But here I'll just print it out again. So when I rbind the list, we have successfully gone to each of those actor pages, extracted out their movies and the years in which those projects were running, and we have some good information here. Okay, and so you can think of ways to use Rvest to go visit a site and scrape the information and even follow links to pull out the information on those following pages without having to manually go to the pages yourself. Okay, so I think that's pretty cool that you can do this in R. And next week I'll probably post another homework assignment where you're going to start to work with RVest and do some kind of activity here. But if there aren't any questions, then we'll end here for today. I hope you guys have a good weekend, and we'll see you on Monday. Do your best with the homework if you haven't finished, and just turn in what you got when the homework deadline rolls around. Okay.